thank you firstly for the opportunity to share this with you today. Geopolitics, as we've just seen, is long-standing in the history of our world and is rarely out the news. And I feel the political stability of countries is really at the heart of it. Governments all over the world are being tested. The West is facing the growing challenges from the expansion of Russia and Chinese influence, as well as dealing with their own internal issues of domestic terrorism and civil unrest. The problems are in the news every day, but how can we actually measure where in the world political instability is getting worse, and indeed where it is getting better? So today I'd like to show you how we can use geospatial data to better understand political stability and introduce you to a GIS that is currently tracking political risk in over 1,500 regions across the world on a daily basis. But before that, I'd like to quickly introduce myself. I'm Lucas Badger. I'm the founder of Sandbox Analytics, and much of my professional experience has been gained within the defence and intelligence community. Prior to Sandbox, I spent a decade working for the Ismaili Imamat, which, as some of you may know, is the supranational entity led by His Highness the Aga Khan, and I specialise in geospatial data, with one of my main areas of work being mapping how political stability is changing across the world. And I feel geospatial data is uniquely positioned to help answer this question. But before we look at how I'm using it at the moment, I'd like to look at how political instability is traditionally modelled. So political instability is an inherently unobservable phenomena, but I'm sure many of you will be aware of the models and metrics used to gain a perspective on it. For example, the Fragile State Index on the left of the slide uses data sets from the international agencies like the United Nations, the World Health Organizations, and they blend those data sets with an expert panel to validate a model and try and compensate for lagging data sources. You'll find similar approaches from other prominent institutions, the Global Peace Index on the right of the slide, with their example. And of course, any large insurance company or bank will usually have a political risk team with a political risk model. Now, the thing these models usually have in common is that they measure political instability at a country level resolution, and typically only on an annual basis. And I think it's fair to say that that's really a limitation of the data sources they're using, and of course makes early intervention by governments very difficult and forces commercial enterprises to be far more reactive than proactive in their decision making. However, with all that said, progress has and is being made with increasing resolution of political risk analysis. Some institutions like the World Bank are starting to bring together subnational data sources like this map shows to provide better modelling of the factors that contribute to political instability. Now, it's excellent work, but it comes with its own set of problems, as many countries still only report poverty rates at the national level, and poverty as a metric can really be described as a lagging indicator of political instability rather than a current measure. However, it was this type of subnational data analysis that was the inspiration that started me looking at how I could use big data analytics to assess political stability at that subnational level and measure it on a day-to-day basis. It's not to say it would necessarily change on a day-to-day basis, but the aim I set out with at the start was to create a model that could recalculate it from a daily source of data. To achieve this, I looked for alternative data sources and found a variety of tools and existing data sets to help with that analysis. So at the center of this slide, you'll see something called the Open Event Data Alliance, and that's a GitHub library and is a brilliant toolkit that can be used to generate political event data using news reports. And what that means is we're classifying news stories using CAMEO coding into event data using something called a political ontology, which is essentially the framework it fits into. We then geocode those events, and in this way we can take daily news stories and turn them about political news and violence and turn them into geocoded, time-stamped event data points. So in addition to generating data from this OEDA pipeline, there's two other data sets. The one at the top, GDELT, which uses a similar approach of OEDA, machine classifying and geocoding news events. And then ACLED on the bottom, which is a human-coded conflict data set. So in a moment, I'll show you a data animation of how machine-led cameo coding works. But I just want to introduce one final part of the process, which is the scale we use to score the political news events and the conflicts events taking place. This slide shows the Goldstein scale, which is a conflict cooperation scale, and you can hopefully see how the different scores are attributed to different types of events. So, for example, military attack scores -10 as very severe, while protests -2.4 being less severe. And this scale was developed by an expert panel and is used to score each CAMEO-coded event consistently. Of course, one can always debate any scoring scale, but with this approach, any bias, it's embedded in the machine coding and therefore preserved explicitly, which means you can recode them if you take a different view. However, perhaps the most important outcome of this scale is that it's able to consistently score those millions of news events that pass through the pipeline, which is currently over 120 million plus events in the model. And that means that where we're seeing any score changes, those score changes must be driven by changes in the underlying reports about political news and events. Anyway, enough of the sort of context. Let's take a look at the data visualization of this process. I'm going to use the build-up to the Russian invasion of Ukraine, and hopefully it will bring together everything I've just talked about. So I'll set off this dashboard, and you'll immediately see the cameo coding taking place and being plotted on the map. The table on the left shows the top-level cameo coding, such as demand, assault, fight. It's worth mentioning there are multiple subcategories within those that can refine the coding and the scoring even further. The red, yellow, green color reflects the Goldstein scoring we have just looked at, and you can see the total number of news reports being processed for Ukraine in the top right. The extra graph run along the bottom is indicative of the quantity of political and conflict news being reported by global media. I've added some text headlines in to give more context to what's driving the spikes. But please bear in mind, we're looking at almost 10 years worth of data in about 2 minutes. So this dashboard runs through to the end of 2021. And the reason I've stopped it there is the data from 2022 would really require a dedicated lecture on Ukraine to do it justice. And today is really about sharing with you how we can measure political instability with big data across the world. So with this in mind, hopefully you can see how this approach of gathering data from the open media sources, processing, geocoding, classifying, how we then build up to 120, 130 million events globally. So I'll jump forward, building on that logic. What do we do next? So once we've classified all that data, it's a bit unusable, as you can imagine, as 1 million plus data points for this Ukraine example. The next step is to aggregate the scoring at a subnational level. And that's what this data visualization is showing. So essentially, we're grouping by ADM1 level, and hopefully you can see how it differentiates risk across the country and correctly identifies the higher risk areas in the east. So this is achieved by doing a sort of leap of faith, where you take all of that CAMEO-coded model and you wrap it within the macro level factors as well, common to many political risk models. So you can use any country level risk model for this. So it's very adaptable for different user groups in that sense. And secondly, as it's important to use a very long rolling average. So each of these graphs is composed of 3 years rolling average data, which means the final metric has very, very strong roots. And so if you're trying to see any variation in that rolling average, it clearly has to identify trends in the political stability or the reporting of it. For example, if a subnational area shows an increasing score month after month, you have to say that the political and conflict news from that area must be getting more frequent and more violent, or both. And this is evident in Donetsk, where the mini graph, hopefully you can see if I hold the mouse, but second from the right of the mouse is not showing through, shows how that's elevated even before the conflict became an invasion. So the next step is to bring that approach up to a global level. So once we've applied that data gathering across the globe, we can then track and change this. We can then track changes in over 1,500 subregions in the same way we have within Ukraine. And this is where we start to apply it and make it, rather than just observing data, we start to say, well, what do we want to do with it? And it's very useful. And the business case here is for asset risk managers, although the same would be true of any collection of assets around the world, such as embassies. I'm sure you'll appreciate that most asset risk managers in the finance sector have their own country risk models, often built in Excel and weighted to their own interests. And so by blending that with that geopolitical risk model, the conflict model you've seen, what we can do is then spatially join it. And this is where we release the power of that geospatial data. And so what this slide is showing is a company which I've renamed ABC Industries for privacy reasons. It shows their assets around the world. And I say by joining their asset database and the country risk political stability model, we're able to then automatically track the political risk of a whole portfolio across the world. So this data visualization shows that tracking in progress. The bottom left score gives the overall portfolio risk. And you can imagine if every company in the FTSE 100 with a global footprint, you are able to compare which one is exposed the most. The dashboard was inspired by the stock market, and it's, with simple data alerts, it does that overwatch of key areas around the world. I think the real value here is not just the resolution of the data, but also the objectivity the model provides. In definitely saying your interests are in an area that is getting politically worse or getting better. And of course, it's recalculating each day, although typically the speed of political change is aggregated monthly for the purpose that very few organizations are looking to respond daily to the macro political environment. I think ultimately the best analogy I've come up with for its value for people is the sense that if you look at a glass of water, you can tell when it's below zero because it's frozen, and you can tell when it's above 100 degrees because it's boiling. But water doesn't give much indication of its temperature. And political instability feels a bit like that until civil unrest erupts or the Russians roll over the border. You know, what are the indicators it was deteriorating? And of course, measuring the temperature of that water is measuring the temperature of that global news. And there is indications across the board that that level of reporting in an area will precede any of those larger events. And so measuring the temperature of the water or the political instability with this approach. So to wrap up the data visualizations, I thought I'd show you some screenshots of the 3D interface I built. It's entirely flyable, but we haven't really got time to fly around the world today. But if we look at Africa, I'm working with a conflict and forced migration organization, and they're looking for low-level conflict indicator to enable early intervention by governments or NGOs. And so looking at how the, if we zoom in, we can see how well it then starts to look at cross-border issues, which of course previous models haven't really been very strong at. So Northeast Nigeria, Niger, Chad, Cameroon, Boko Haram operate, and other anti-state actors operate across that, those four countries and exploit the lack of coordination between governments. And of course, by measuring with this model, you can see how that aggregates subnationally in the corners of those countries. The visualization actually works by filling up the containers, which is why they look empty, one layer a month for each data, much like a rock strata in a container. And then you can fly around visualization, time slider, and you can actually watch how the threat displacement takes place when perhaps Cameroon launches operation to push Boko Haram out. We actually see the metrics increase in the surrounding countries through that threat displacement as they push the anti-state actors into each other's countries, hence making the case for stronger coordination. That, I think, is the end of my presentation. So in summary, I hope I've explained how we can use that big data approach to measure political stability in a consistent way at a subnational level. It does provide that higher resolution insight, and essentially we want to make better decisions, whatever our interests may be. Looking to the future, I'm keen to advance those geocoding standards for the news reports, as I found. The better the geocoding, the earlier a political trend is apparent. I also think geocoding in news events can help extend this type of modelling into new areas like economic event data. Secondly, I'm looking to blend in more data sets to provide more insight. So if anyone's working in modelling conflict or conducting political risk analysis or is aware of others in this space, please do connect with me. And finally, I'm very open to sharing the data. I have a very strong belief that progress in this space is far more than profit, which is why I share exactly how I do it to help essentially progress the world's insight into political instability. So please get in touch if you have an application for the data. Thank you, and please let me know if you have any questions.
Thanks very much for that presentation, Lucas. I think it was a brilliant one to follow up with from Alex and James's presentation, actually. So it was great to see, and yeah, certainly with the animations and how they've taken off and make the data really useful, actually, in this context. We've got a first question in. Check it is the first one. Are there ways to link political instability to economic instability?
Yes, they're not discrete. So when the macro model I spoke about, which we wrap the micro modeling in, that contains economic indicators from the World Bank. And really, it depends on that macro model if you want to talk about political or if you want to raise it up to country risk, which could be considered a combination of political, economic, etc. So it's the macro modeling that really defines the ultimate measure. The subnational modeling, we want more economic subnational data in there, but there's quite a lot in the macro already.
Thank you. There's no more questions in the chat at the moment. I'll just give people a couple of seconds to add anything else if there is anything that they're wanting to ask Lucas. We're all keeping really quiet, Lucas, so it might be you can get off without having to ask any more. Well, so Alex has just asked a question. So he said that it's a fantastic, fascinating, Lucas. Thank you. What extent do you think the maps are accepted universally? What Alex asked.
The visualizations.
I presume so. Yes. Yeah.
I think whenever you show people a view, so if you dealt with a Chinese company looking at their distribution of assets, they will have a very different view on their assets in China than an American company, which is why I always come back to you can dispute the reporting, you can't really dispute the events that go on, but what they mean to you will vary, depend on your own profile. There's no such thing as a good and bad country, for example. Just it's a perspective on your interests. And so the key is to enable the users who take this approach to use their own macro models so that they have a very positive view of North Korea for whatever reason they do. This model won't tell you North Korea is a bad country, but it will say, okay, you think North Korea is the second best country in the world, that's fine. But even within that view, these are the areas that are less good within North Korea. It is differentiating your view, not telling you what countries are good and bad.
Excellent, thank you. And Seppi's asked another question. So could this could this approach actually influence how the media represents events?
It could. It's not something I've shared it at a couple of conference nows. I've used it just within my own support. I'm looking to expand it, and it may grow into that space because of the growth of the ESG interest, the environmental sustainability governance, and the governance now is not just an internal factor. Geopolitics seems to have entered the debate for huge amounts of supply chains and interests. And so I was approached last week about getting this as an ESG data set and saying this is a new way to see geopolitical risk. And so that's going on at the moment. And so I think if it got into the mainstream commercial world, we might see the media, start to sort of recognise it. And with all these things, it's got to establish its own credibility as a useful data set.
Yeah, absolutely. And Claire's just said it's really interesting. Claire from Steer has confidential clients that could be interested in your work, Lucas, so she's going to be in touch with you. So
good news.
Really positive.
Thank you, Claire.
I'm going to wrap up there, Lucas, because I'm just aware of time. Thank you very much for taking part today. It's been a really interesting talk, and thank you for your time.
Pleasure. Thank you.